Occupying most of the Arduino's digital pins just for the keypad is not an efficient use of our hardware. Although Demo 1 was simple to put together and make it work, it isn't good enough for practical use. In Demo 2A and 2B, we'll improve the design so that a single pin is used on the Arduino to transmit button pressing information. We'll do this using two different scripts, but the same hardware design. Let's start with the hardware. Have a look at the schematic. First to notice is that there's only one wire, marked in orange, that connects the breadboard to the Arduino. The black and red are for power. The connected pin is analog 0. This is really nice, as from the 8 digital pins we used in Demo 1, we have reduced the count to just 1. Next to notice is that the breadboard is now fairly busy, with a series of resistors and diodes arranged in rows and columns. With the assistance of these resistors, what we are doing is that when a button is pressed, current flows through a unique path that includes a unique combination of one of the vertical resistors and one of the horizontal resistors. The combined resistance is unique in the sense that no other key press can match it exactly. Therefore, that voltage as sampled by the Arduino analog pin 0 will be unique for each button. Based on that voltage, the Arduino will be able to detect the identity of the key that was pressed. In the notes for this lecture, I have included a table that shows you the resistors that I have used in my demo. Okay, so in the previous demo we saw how we can connect the matrix keypad to the Arduino essentially in parallel mode, and that was using up 8 of the Arduino's digital pins. Didn't leave much room for expansion or for anything else to be connected. So I thought I'd show you how you can connect the same keypad to the same Arduino using only a single data pin. Of course, we still need power for the keypad. The way to do this is that we're going to use an arrangement of resistors to create what's called a voltage ladder or resistance ladder. Have a look at how this works. Have a look at this schematic. So what we have here is our keypad, represented by these buttons working as switches, and a set of resistors and 4 diodes as well, plus a ground resistor down here. Imagine now that I press this button. What's going to happen is that the current is going to flow this way from 5 volts through the 1 kilo ohm resistor, then through my button joint, and then down. It's going to go down this way, eventually through the diode, and then it's going to be sampled by the Arduino using its analog input. So that's going to create a certain voltage here that the Arduino will be able to read. Now let's say that I press this button here instead. What's going to happen is that now current is going to flow from the 5 volt pin from the Arduino through the 2.2 kilo ohm resistor, and go through this switch and route it downwards through the 220 ohm resistor, then through the diode. Some of it is going to end up, the voltage at this point is going to be sampled by the Arduino through the same analog port as previously, and then some current is going to escape as well through ground. But the point to notice is that in the second example, when I pressed the second button, this one here, electricity flowed through a different circuit and a different set of resistors as compared to when I pressed this button here. So essentially the Arduino is going to measure a different voltage here. So I'm selecting the resistors so that every time that I press any of those buttons, the Arduino measures a completely different voltage at its sampling pin here. So these values for these resistors are not by chance, of course. They have been calculated to make sure that no two buttons when pressed will produce the same voltage down here. So let's have a look at the circuit in action first, and then have a look at the sketch. I actually have two sketches to show you. Let's upload the first one. Alright, so let's press a few buttons and see what happens. Alright, button 4. Okay. So what's happening here is that the first number represents the voltage that was measured by the Arduino using the analog pin 0 through the orange wire, and the second number is representing the value. The key that I pressed. So in this case, it was 2. And it's going to be 3, that's A, and voltage 599, or reading 599 to be more correct, 4, 5, 6, 7, sorry, B. You noticed here that I press the B and a 6 comes out. I'll explain why that happens in a minute. Press 7 and 8 comes up, and press 8, correct, 8 comes up, press 9, 9 comes up. C is correct. I've got 0 instead of star. I've got hash instead of 0. I've got D instead of hash, and D is correct. Let's have a look at the sketch, and then I'll explain why we've got a few errors in the readings. So in this sketch, we start by defining a string that contains the keys and the symbols that appear on the keypad. So the position here is important because number 1 is going to appear when Arduino makes a measurement of a certain measurement on analog pin 0, and then the number 2 is going to appear when key 2 is pressed, which is going to produce different voltage in analog pin 0, and so on. I'll leave this aside for now, come back to those later. In setup, we initialize a serial port. In the loop, we call the function getKeypad, which is defined further down. So let's go ahead and have a look at this function now. So here's getKeypad. We start by defining a local integer variable. It just tells us whether a button has been pressed or not, and whether then the next one is reset lookout. Is a boolean that we use to ignore multiple closes of the switch. Because what happens sometimes is that when you press a key, within a few nanoseconds or milliseconds, multiple key presses are registered by the Arduino because the switch is not perfect. So we don't want to generate multiple key presses just because physically this is what's happening. We just want to register that one single key press that we have actually done. So then we take a read of the analog port 0, and if it's 0, which means that we have no key press, then we don't log our key read. Otherwise, if there is a reading, then and there is no key lockout, then we'll go ahead and process that key press. We first delay any further action for 20 milliseconds, so we wait for the key press to settle. In this case here, I'm printing the value that we've just read, and then we do this calculation. Now this calculation and the numbers that you see here eventually yield a simple number, which is going to be within 0 and 15. The way by which this formula has been calculated is mostly through trial and error, and it depends upon the exact measurement of these resistors that I've got here. And because the resistors that I used this time around compared to when I've done this circuit in the past are slightly off, maybe 0.5% off, then these numbers don't no longer match my resistors. And that's a problem when you use this kind of logic in your program. I'll come back to this in a minute as to how we can go around the problem. Then we are going to lock our keyboard for a few milliseconds in order for this transient key press effects go away. Eventually we're going to return the number that we calculated here, and back in the loop function we're going to enter this block, and we are going to print out the appropriate character from this string. We're treating this string as an array. We're going to go to one of the cells of this array, and that's represented by the number key that was returned by this formula. And let's say that we press number 1, then this formula is going to calculate 0. It's going to return 0. So we're going to go to keys at position 0, which is character or symbol 1, and that's what's going to be printed out. So it's a fairly simple, at least in terms of size, sketch, but this is a significant vulnerability. Pretty much every time you make the same circuit, even if you get resistors with the same values, at least advertised same values, because of the tolerances that they have, the total resistance every time you close a circuit is going to be slightly different. So this form is going to be slightly off, resulting to inability to produce the right characters in the output.